Assalamu alaikum. Rabbi shrah li sadri wa yassir li amri wa ahlul 'uqdatam min lisani yafqahu qawli. Oh my Lord, give me your courage, give my word the depth, so that what I am trying to explain reach my audience and they are able to understand the content what I am teaching. This is a very simple problem of or the model of trip generation. Model means an equation that has been derived through regression of collecting certain data. The first, uh, there are two problems that I'm going to solve. Let's see the first example. It says the following regression model is developed for a study divided into four zones. 1, 2, 3, and 4, as you can see from the table. It has this relation minus 43.66 plus 0.09 times the production, then 0.773 times the employed people in that zone, then minus 3.351 times the household X3 plus 0.504 times the number of cars in that area. This is not population, this is not production, this is population. I'm sorry for that. Now what you need to know, estimate the number of reproduced from each zone using the following data. So we have zone 1, 2, I've tabulated like this. This is, again, this is not production, this is population. And we have these number. What I'm going to do is just plug this value into the same order. This is x1, this is x2, x3, and x4, and find the calculated trip per day. For instance, I have calculated, I have shown here how this value is calculated. So this is minus 43.6, so this will remains as here, plus 0.097 times x1. Now I have placed x1 by 15,000. Then there's plus 0.773 times x2. x2 is 6020 over here. Then minus 0.351 times 3020 plus 0.504 times 5,000. So that makes 7525.4. Similarly, for zone 2, we'll say minus 43.6 plus 0.097 times 12,000 plus, now I'm interested in this row. So then 0.773 times x2 means 0.773 into 7050 minus 0.351 into 2050 plus 0.04 into 4,000 means that from zone 2, 7,867 trips produced per day. Now, in the third, for the zone 3, minus 43.7, 43.6 plus 0.09 times x1 is 9,000 plus 0.773 into 5,200 minus 0.351 into 1750 and plus 0.504 into 3,000 is 5747.35 trips per day. For zone 4, minus 43.6 plus 0.097 times 8,500 plus 0.773 times 3950 minus 0.351 times 2,100 and plus 0.504 times 2,500 is 4,357.75. So we can say from the given data, zone 2 is producing the highest number of trips, 7,867 67, despite of the fact that it has got lower population than zone 1. And zone number 4 is producing less number of trip, and which can be seen that every parameter, 8,500, all those parameters here are always the parameters for the popular zone 4 are less than each of the number except this value household, because but since this has a negative impact, that's why it has got this trips. So this is how one way of knowing the trip generated from one zone. Another way is we called a cross classification. Uh, it says an urban zone contains 200 acres of residential lanes, 5 to 50 acres devoted to commercial uses, and 10 acres of park lanes. The following table presents the zone's expected household composition and some future target area. So we are again interested in knowing the trip generation from each zone. It says that, you know, car per household, 0, in the household having one person, it's producing 100 trips. 2 to 3%, it's 200 trips. 4 person having no car is getting 150 trips, and uh, 5 persons are producing 20 trips. So similarly for that, now we want to know trip generation. So what we need to do is we'll take the first thing first. For one person having 0 car hold, 0, 1 and 2, a car per household will have this 100 into 0.57. And where this 0.57, this is the table. In a high density urban, if you have one person per household having 0 vehicle, the factor is 0.57. So since there are 100 people, so that's why we have multiplied 100 into 0.57. Similarly, for 1.45 and 1.82. This is the first part. Then for the second column, it's 200, 500, 100. So what I've done is 200.95. I'm sorry about this 20. This is not 20. Or what we have done is it can be from this manner as well. 100.47, 202.07, 4 point of then this 150 into 4.57, and then 20 into, and then 20 into is 6.95. So we are going row wise, and when we add all those factors, remember these bracket factors are from the research that we says that how total home base non-work trip return. So what these values we have taken from the table. So we adding all those, we find that this is 558,760 trips are made in this area. And since the total number of household is 1840, how we have estimated 1840, we have just add all those numbers from 100, 200, 150, 20, 300, and that we found 1840. And this once we have known this, trip per household, so trip per house per day, total number is 58760. Again, there's an error in here, and then 1840, this becomes 3.13 trips per day. So that's how trip generation problems are solved, and we can estimate how many trips are produced from each zone. So that's it for today. I hope you have fully understood what I explained to you. Thank you and take care.